This is Mr. Precella working with this trigonometry class. Today I thought we'd start off looking at the unit circle and review filling in these points of intersection. And then once we do that, we're going to fill in the radian measures. Okay? But first of all, I'm going to fill in these points of intersection. I'll do the quadrantal angles first. Those are the four that actually are on the x-axis and y-axis. I got this unit circle from embeddedmath.com. I filled in the degree marks and I added a little color to mine. Y'all are living in a black and white world. The four pink angles, if this is a circle with radius 1, these points of intersection would be right 1 up 0, but here at 0 degrees. At 90 degrees, over 0 up 1. What about here at 180 degrees? What would that point of intersection be? That would be left 1 up 0. Call out if you have any questions. Just sort of recapping what we did on the last class period. Here at 270 degrees, remember the radius of the circle is 1, so this point here would be over 0, down 1. The significant thing about these points of intersection is those points of intersection are in the form cosine theta, comma, sine theta. Now, let's do the blue ones, the 5-degree ones, the ones that have 45 degrees, that's the reference angle. These are the ones that end in 5 degrees. Do you remember what numbers go here and here? We went through in class the other day and tried to justify them, but now it's just a matter of do you remember them? It's the square root of 2 over 2. And then you're going around from quadrant to quadrant. In quadrant 2, x is negative, y is positive. So it's negative square root of 2 over 2, comma, positive square root of 2 over 2. And 225 degrees in quadrant 3, they're both negative. So negative square root of 2 over 2, negative square root of 2 over 2. And finally, at 315 degrees, x is positive, y is negative. Now let's do the yellow angles. Those are the ones that have 30 degrees as the reference angle. Those are the four that are closest to the x-axis. So first, all the 5-degree ones, the ones that end in 5 degrees, it's square root of 2 over 2. The SIGN sign is changing as you move around from quadrant 1, 2, 3, 4, and so forth. But they're all this same square root of 2 over 2. What about at 30 degrees? Ooh, I can't use a yellow ink. I don't have a yellow ink. So I will use orange. 30 degrees, which one of these looks, it's going to be the square root of 3 over 2 and 1/2. Which looks bigger? If you imagine the triangle for 30 degrees, is the horizontal or the vertical bigger? The horizontal or the vertical? Which one looks longer? Not a trick question. The horizontal looks longer. I think this horizontal distance looks longer than this vertical. That's how I remember which number goes first here. It's either square root of 3 over 2 or 1/2. Well, since the x is bigger, 3 is bigger than 1, square root of 3 over 2, 1/2. 30 degrees, the x distance, ooh, that's square root of 3 over 2. My orange doesn't want to show, so I will try, let's see if this works. Square root of 3 over 2, 1 over 2. Does that make it any darker? Yeah, okay. Then moving around, the other four, the ones that are closest to the x-axis, X is negative, y is positive. At 210 degrees, they're both negative because you're in quadrant 3. 330 degrees, X is positive, y is negative. Then the four that have 60 degrees as the reference angle, I don't have it colored because all I'm going to do is take the 30 degree ones and switch them. The X, notice how the horizontal length is smaller than the vertical length. So I'm going to put the smaller number first. That's the 1/2, comma, square root of 3/2. 1 is smaller than that 3. Like right here, the X, the horizontal distance looks longer than the vertical. That's how I remember it. Sometimes students give me some other ways they remember it. 0, 1, 2, 3. You'll see what I just did starting up at the top. Look at the X value. 0, 1, 2, 3. Somehow you're going to have to remember these. So in quadrant 2, X is negative, y is positive. At quadrant 3, they're both negative. In quadrant 4, X is positive, y is negative. So, really need to have these values memorized one way or another. This is a huge or a significant breakthrough. Just knowing that, if someone asks you, what's the sine of 120 degrees? The sine of 120 degrees, square root of 3/2. The first number's the cosine value, the second number's the sine value. If someone asks, what's the tangent of 270 degrees? Tangent, you go sine over cosine, -1/0, undefined. Okay? So there's no way around knowing this, how to label this unit circle. Okay? Now let's fill in the missing blanks. We didn't do this the last time. The radian measures. Well, I know we just saw the little formulas. Multiply by pi over 180 degrees, or else multiply by 180 degrees over pi. We went through all of that so that I can now tell you that's not how I'm going to do this here. That would take too long if I'm going to fill in all these little blanks here. So how am I going to do it? Well, I use the fact that 180 degrees is equal to pi. I'm using that fact that 180 degrees is pi. And so right here at 180 degrees, I'm going to go ahead and fill in pi. I'm now going to label, well, 0 degrees is 0 radians. I'm labeling the four angles that are on the x-axis and y-axis. I start with my thoughts being 180 degrees is pi radians. 90 degrees would be 180 divided by what? 2. 270 degrees is 90 times what? Yeah. 3 times 90 is 270. So for 270, I'm going to write 3 pi over 2. 3 pi over 2. Now what about 360 degrees? If pi is 180 degrees, 360 is 2 pi. Now see how I'm labeling these. I'm not going to go through doing this times pi over 180 degrees for every one of these angles, or it's going to just take me way too long to get it done. Let's do the four that have 30 degrees as the reference angle. That's the four that are closest to the x-axis. Okay, 30 degrees is 180 degrees divided by 6. Did y'all hear that? Pi over 6 for 30 degrees. And I get this first one by thinking 180 degrees divided by 6 is 30 degrees. Now to get the other three, the ones that have 30 degrees as the reference angle, or the yellow angles, whatever you want to call them. It's the four that are closest to the x-axis. I'm going to do multiplication. What do I multiply 30 by to get 150? 5. So it'll be 5 pi over 6. What do I multiply 30 degrees by to get 210? 30 times 7. 7 pi over 6 would give me 210. 330 degrees. What do I multiply? What do I multiply 30 by to get 330? Well, 11. 11 times 30 is 330, so 11 times pi over 6. Under document sharing, I have the completed version of this with the type numbers from embeddedmath.com, or you can just go to embeddedmath.com and see it looking a lot neater than this, with actually type numbers rather than the handwriting. I know my handwriting's a little difficult to read. So let's see. The 5 degree ones I think are the ones that are the most difficult to remember. I will fill those in with, no, not purple, blue. Okay, 45 degrees. Well, 180 divided by what would give me 45 degrees? 4. 180 over 4. That's a pi over 4 I wrote for 45 degrees. Now go around to all the 5 degree ones and use multiplication. What do I multiply 45 degrees by to get 135? 3. So it's 3 pi over 4. Getting a little bit tougher, the 225. What do I need to multiply 45 by to get 225? 5. And sometimes what you notice the pattern. 1 pi over 4, 3 pi over 4, 5 pi over 4. If you had to guess, what's the next over 4 one going to be? 7 pi. 7 times 45 is 315. Oh, I'm not sure why the 5 degree ones are the ones I think, I guess in the multiplication, 45 times 5, 45 times 7. I think those are the most involved ones, but that might just be me. Now we're going to do the 60 degrees. 60 degrees would be 180 divided by 3. 120 is 60 times what? 2. So I'm saying 2 times 60 is 120. What do I multiply 60 by to get 240? 60 times 4. So 4 pi over 3. Only one left. What do I multiply 60 by to get 300? 5. 5 times 60 is 300. Any questions how I did that? I don't recommend that you do that times pi over 180 degrees for every one of these. Or I'm not going to say you'll never get it finished, but it's going to take a lot longer. I have a blank one of these there on document sharing so that maybe you could print it out and practice more if you need. Okay? So let's start using the unit circle to do the next homework problems. Okay? So, any questions on this before I'm about to do away with it? Okay? We'll be looking at the typed version as I do the next examples in class. Oh, So this is Anthony Precella. Thanks for watching.